Hey everybody, this is Mr. Matthew here again, and this is our fifth and final video in the From Molecules to Organisms series. In this video, we're really going to focus in on photosynthesis and the use of light energy to transform water and carbon dioxide into oxygen and chemical energy that is going to be stored in the bonds of sugar and other carbohydrates. And so in this particular case, what we're going to do is we're going to review and rehash the general formula for photosynthesis. And then we're going to provide a little bit of context for what goes on in ecosystems and how photosynthesis is connected to energy in ecosystems. And we'll make some additional connections to the flow of energy within those ecosystems. All right, so here we go. So let's start with our equation for photosynthesis, which you guys should all be familiar with at this point. And that is that you have 6 carbon dioxide and 6 waters in the presence of light energy, and that's going to form 6 glucose molecules and 6 oxygen molecules. And so again, sugar is glucose in this instance, or other simple monosaccharides. In this case, C6H12O6 happens to be glucose. So when we look at the actual organism and we see the tree here, we can see that, well, water is going to come up through the roots, right? And we see carbon dioxide coming in from the air. That's how we get our 2 reactants. We also see sunlight coming in, and that's what's going to drive this, along with a lot of enzymes and structures that we could go into much greater detail on, but we're not going to. And then as a result, we're going to actually make some sugars, then those are going to be retained by the plant, and we're going to release oxygen as a byproduct. So again, you can see a different form of that in the upper right here, with all of the appropriate compounds and structures that are involved. So again, solar energy driving the conversion of carbon dioxide and water into, in this case, they label it as starch, because we know that when we take multiple glucose molecules and put them together, we form starch, and that's actually what's retained inside the cell. We also have sap going up or down from the stem over on the far side, and that's just a reminder of things like making maple syrup, and in this particular case, we're talking about a maple tree based off the leaf shape. So how does this involve the transformation of energy? Well, we know that the energy in the form of sunlight comes down to producers, and we also know that there's some heat that comes from the sun as well. But the producers are going to harness that solar energy, and then that solar energy is going to be either taken in by consumers or animals that consume those producers, or it could be when those plants die and they decompose, it could be consumed by decomposers. Similarly, what we will see is that when animals die, the decomposers will consume them. And throughout this process, in the arrows here, we see that decomposers are going to release heat, but it's also true that both producers and consumers are also going to be releasing heat throughout this. So what we're seeing is ultimately this one-way flow of energy from the sun to organisms and the dissipation of heat throughout this system. We never see energy going backwards, and so if you remember, energy has a one-way flow through ecosystems. It is always from the sun to producers to consumers, and that would include both the consumers on this and the decomposers, and ultimately it's all going to dissipate as heat as a byproduct of the metabolic processes of these organisms. So what I want you to do is I want you to pause and think. And I'd like you to pause and think and identify what you think the green, the blue, the white, and the red dots are represented in this model of the carbon cycle. So why don't you pause and think? All right, so hopefully what you came up with in this is that the green represents sugar. This is something that's made when all these different components come out as a product of photosynthesis. You see that the greens are actually being formed right on the word photosynthesis, and so that's a key sign that photosynthesis is producing those green sugar molecules. The water is the light blue molecules, and again, coming up from the ground, up the tree, and is actually coming together, and that's what's one of the reactants of making those sugar molecules. CO2 is the other reactant. It's actually when the CO2 and the water come together at photosynthesis that you make the sugars. And so those little white circles are going to be the CO2. All right, so hopefully what you see is that those oxygens, those little red dots, are actually driving as a reactant in respiration in the case of soil respiration or animal and plant respiration, or being given off in forest fires or in the burning of fossil fuels. We have oxygen driving those, and as a result of that, they're being converted from oxygen to CO2. And so oxygen is a key reactant in the respiration or the formation of the CO2 through fire. Okay, so to make CO2, you're going to use those oxygen. So this is a nice interactive, and it hasn't made you too dizzy, and it's given you a foundation of the cycling of elements through the ecosystem. All right, so now what we're going to do is we're going to take a step back and we're going to talk about photosynthesis and connect it to that overall energy flow. So again, I'm going to beat this drum again that what we're going to see is a one-way flow of energy, but this is also going to be tied to the limitations of matter at each of the different levels within the ecosystem. And so over here, what we see is sun, and the sun is going to come into the plants, and there's going to be a wide level of autotrophs or producers here. And then what we're going to see is that they're based off of the breadth of producers, we're going to be able to support a certain amount of herbivores. And we're going to see fewer herbivores than we see producers because the energy is going to be dissipating as heat off of the plants as they use the energy in order to drive their activities. We're then going to see fewer primary predators of those herbivores than we do have herbivores for the same reason. As the herbivores consume that energy and use it for their daily activities, there's going to be energy dissipating as heat, and as a result, there's going to be less available energy on that next level up. And then ultimately on that secondary predator, or that top consumer in this case, looks like we have a fox in this case, you're not going to have much available energy because again, energy is going to dissipate as heat off of these levels, but you will be able to support one. And so whether we represent it as an energy pyramid on this side or as a food web on this other side, you can see that there are many connections between these ecosystems, but fewer available calories within the ecosystem to those high order predators than to the producers that can make their own calories. All right, so hopefully at this point you could illustrate using a model how photosynthesis uses sunlight to transform water and carbon dioxide into chemical energy and also releases oxygen as a byproduct, and that we then store energy in those chemicals of sugars or other carbohydrates like starch. Also, you should be able to connect the inputs and outputs of matter transforming from one form to another, and that was really seen in our carbon cycling. You could also model through diagrams, chemical equations, conceptual models, the flow of energy. In this case, we're looking at either an energy pyramid or through something like a food web or even possibly a food chain, how energy is transferred through the ecosystem. Again, we could have gotten into a lot more detail about the actual process of photosynthesis down to the level of light reactions and Calvin cycle or other chemical structures of molecules involved. And those are not going to be on the state assessment. So those are beyond the scope of the course. We may bring some of those up in class, but you're not going to be assessed on any of those. All right, so I hope that was a helpful review of photosynthesis, and I'll talk to everybody soon.